Very good morning, my dear students. So, in this session, we are going to discuss Unit 7 Thermodynamics, Pressure Volume Work, Zeroth Law of Thermodynamics, First Law of Thermodynamics, Enthalpy, Standard Heat of Formation. The first question: derive work involved expansion and compression process on the system. For understanding pressure volume work, let us consider a cylinder which contains n moles of an ideal gas fitted with a frictionless piston of cross-sectional area A. The total volume of the gas inside is initial volume and the pressure of the gas inside is internal pressure. So in this case, work is done on the system. So plus W, it can be calculated as follows. We have known very well, work means force into displacement. Here, displacement is nothing but change in volume. When we apply the external pressure, the volume changing is occurring. The change in volume, the distance is very less. That's why W equal to minus negative symbol takes place because distance decreases. Final volume is less than initial volume. So W equal to minus F del X, change in volume del X. The change in volume, distance is decreases, that's why negative symbol. Next, we know that pressure equal to force by area. Pressure equal to force by area. Now, what is force from the pressure? So when we make a cross multiplication, pressure multiplied with A equal to force. Just to substitute the 2 in 1, we can get force equal to pressure multiplied with the area, the pressure external pressure. So W equal to, in the place of force, just to substitute pressure into area minus dx. This is equation 4. Now, area into change in volume del x. So, how can we write it? Final volume minus initial volume. When we apply the external pressure on the cylinder, the change in volume occurs. Final volume minus initial volume. Now, W equal to minus external pressure, change in volume, final volume minus initial volume. This is equation 6. Now, the change in volume, how can we write it? Minus del V. Del means change. Now, two negative symbol is occurring. So by the way, we can get it positive. W gives positive external pressure and change in volume. Since work is done on the system, it is a positive quantity. Suppose the work is reversible. So reversible, what is the sign in the reversible work? The reversible process work equal to negative integral the limit Vi and Vf initial and final volume external pressure multiplied with the change in volume PdV. In a compression process, external pressure is always greater than the pressure of the system. So how can you write it? External pressure equal to internal pressure added with the change in pressure. In an expansion process, the piston is coming up. So external pressure is always less than pressure of the system. So external pressure equal to internal pressure minus change in pressure. This derivation come under 5 mark. Now the reversible process work, you have to write it, depends on the internal pressure. For a given system with an ideal gas, this equation is compared with the ideal gas. Ideal gas formula in gaseous state we have known very well. PV equal to nRT. PV equal to nRT. So internal pressure alone, if you want to take, means the V will come into the denominator. So P internal pressure equal to nRT by V. Just you substitute the internal pressure in the reversible process of work. So we can get it. Reversible work equal to minus integral Vi Vf limit applied. The place of P, just you substitute nRT by V dV. So we can get it. The nRT by V take as a common. So dV by V, after integration we can get it. Ln V will come. After applying the limit, the reversible work equal to minus nRT ln Vf divided by Vi. Now ln equal to 2.303 log. Just you substitute the value. The reversible process work equal to minus 2.303 nRT log Vf divided by Vi. Here Vf final state of volume is greater than initial volume, denoted as expansion. The sign of the work done by the process is negative. Expansion means final volume is greater. The sign will be negative. Compression, initial volume is greater. The sign of work done on the process is positive. Question number 2. It is very important. 3 more question. State zeroth law of thermodynamics. For example, you have to take 3 heated red brick at a different temperature, A, B, C, different temperature. Now these 3 red bricks combine with each other. So what will happen? At a time, the 3 different temperature should give equal temperature. Why? Because in thermal equilibrium. So how can we write the statement? If two system is nothing but heated red brick are separately in thermal equilibrium with the third one, then they tend to be in thermal equilibrium with themselves. Question number 3. First law of thermodynamics. First law of thermodynamics. Del U means internal energy, change in internal energy, final internal energy minus initial internal energy. There is a difference. Change in internal energy means final minus initial. So U2 minus U1. According to the first law of thermodynamics, del U equal to Q plus W. Work is done on the system. Work is done by the system is del U equal to Q minus W. So this formula belongs to first law of thermodynamics. Now, so what is Q? Amount of heat supplied to the system. W, work done on the system. That's why the sign is positive. Question number 4. Statement of first law of thermodynamics. So we have known very well, already we have seen the first law of thermodynamics statement. Now some various statement we can find it. First one, whenever an energy of a particular type disappear, an equivalent amount of another type must be produced. The first law of thermodynamics is nothing but energy can neither be created nor destroyed, but may be converted from one form to another form. The same statement. So energy disappear, an equivalent amount of another type of energy must be produced. Point number 2. Total energy of a system and the surrounding remains constant or conserved. So any system, solid, liquid or gas, so anything we can make in which we can make thermodynamic study, the total energy of a system and the surrounding remains constant. It belongs to first law of thermodynamics. So point number 3, as usual, the energy can neither be created nor destroyed, but may be converted from one form to another form. Point number 4, change in the internal energy of a closed system is equal to the energy that passes through its boundary as heat or work. For example, the hot water is kept in a beaker. Now, the beaker condition is closed with the lid. So, what will happen? After some time, the heat will escape out. The heat will escape out to the surrounding. So, how it escapes out? The outline of the beaker with the lid is called a boundary. That's what is given. The change in internal energy, the hot water energy, heat energy, stored energy of a closed system is equal to the energy that passes through its boundary as heat or work. So from the boundary, the heat is transferred from system to surrounding. Belongs to first law of thermodynamics. So one form to another form, the energy is changed. Point number 5. Heat and work are two ways of changing a system. That is internal energy. So heat and work is a path function. Just you remember. Question number 5. So what are the mathematical statements of first law of thermodynamics? Case 1. We know that first law of thermodynamics means del U internal energy, change in internal energy equal to Q plus W. The case 1. First you write the formula del U equal to Q plus W. Now del U equal to 0. Del U equal to 0. Del U equal to 0 means the right side W will come into the left side. So what will happen? Minus W. So Q equal to minus W. Next, case 2. In case 2, isochoric process. The thermodynamic process, isochoric process means what? Volume is constant. So change in volume equal to 0. Now regarding the first law, del U equal to Q plus W. W means what? The pressure volume work final expression W equal to minus P del V. Just you substitute. So we got the change in volume equal to 0. So del U equal to QV. And suffix V is given in Q. So what is the meaning? Constant volume. Constant volume. Next, case 3. In case 3, adiabatic process. Adiabatic process. Adiabatic process means what? Q equal to 0. Q equal to 0. Now, after substitution in the first law of thermodynamics, del U equal to W, because del U equal to Q plus W, Q equal to 0, del U equal to W. Let us see the case 4. Case 4, isobaric process. Isobaric process means pressure is constant. So del U equal to Q minus P del V. The pressure volume work is done on the system. The final expression W equal to minus P del V. Here already the pressure is constant. So until this equation is stopped. So mathematical statement of first law of thermodynamics, case 1, case 2, case 3, case 4 are discussed. Now enthalpy, the most important term used in thermodynamics. Enthalpy denoted as H, capital H. Enthalpy means what? It's a heat. Internal energy added with pressure multiplied with the volume. So any system may be solid or liquid or gases. After heating, it has some energy, stored energy, that is the internal energy U, and the pressure and volume also having. So internal energy is added with pressure volume gives total heat, right? That's why H equal to U plus PV. That formula is used. Now, change in heat, change in enthalpy, del H equal to del U. Internal energy will change. So, change in internal energy del U plus constant pressure, change in volume, del V. So change in enthalpy, what is a mathematical relation? Del H equal to del U plus P del V. Finally, del H equal to Q at a constant pressure P. How the del H equal to Q constant pressure P? We will see. In question number 7, we can find del H equal to QP. The relation between enthalpy and H, enthalpy and internal energy, enthalpy and internal energy. First you should write enthalpy H equal to U plus PV. H equal to U plus PV, we have to write it. Now the initial state H1 equal to U1 plus PV1. Constant pressure is maintained. So in P suffix nothing will be. So H1 equal to U1 plus PV1. Next, in the final state, H2 equal to U2 plus PV2. Next step, change in enthalpy. Final state minus initial state. So H2 minus H1 equal to U2 minus U1 plus P V2 minus V1 at constant pressure. H2 minus H1, how can we write it? Del H. U2 minus U1 del U, V2 minus V1 del V. So del H equal to del U plus P del V. Change in enthalpy. Now, as per first law of thermodynamics, del U equal to Q plus W. Del U equal to Q plus W. Now, del H equal to Q plus W plus P del V. Q plus W plus P del V. Here W equal to minus P del V. W equal to minus P del V from pressure volume derivation. Just you substitute here. So in the place of P del V minus W, so plus W minus W will cancel. Finally we can get del H equal to QP. QP. The QP is a heat absorbed at a constant pressure and is considered as heat content. Heat absorbed at constant pressure and is considered as heat content. Question number 8. What is the relation between ideal gas equation and enthalpy? What is the relation between ideal gas equation and enthalpy? Consider a closed system of gases which are chemically reacting to form gaseous products at a constant temperature. So in a vessel, closed vessel, the gaseous molecules are filled. Now the initial volume VI and the final volume VF as the total volume of the reactant and product gases respectively. Here number of moles initial Ni and Nf as the number of moles of gaseous reactants and products. So better equation, hydrogen combined with iodine at equilibrium, they give 2 moles of hydrogen iodide. Reactants and the products are gaseous molecules. That equation we can take as an example, right? Now for the reactant initial state, we know that PV equal to nRT for ideal gas equation. The condition is gas, that's why ideal gas we can take it. So initial PVI equal to Ni RT. Now for products final state PVF equal to NF RT. Now change in volume, change in the number of moles. How can you write it? P Vf minus Vi equal to Nf minus Ni multiplied with RT. Then change in volume del V, P del V equal to change in number of moles del N, the condition is gas, state is gas, RT, gas constant RT, temperature in Kelvin. So P del V equal to del Ng RT. Finally, just you substitute the P del V in enthalpy, change in enthalpy. Del H equal to del U plus the place of P del V we can substitute del Ng RT. Question number 9. What is the standard heat of formation? What is the standard heat of formation? So any substance it has a standard heat of formation. So how is defined the change in enthalpy that takes place when 1 mole of a compound is formed from its element. So present in their standard states. So how much temperature? 298 Kelvin and pressure 1 bar pressure. So the substance we have to take it. So from the elements, so how much amount we have to take? From the element, it gives 1 mole of a compound is formed. The parameter, 2 parameter we have to maintain it. One is pressure, another one is temperature. Pressure must be 1 bar, temperature 298 Kelvin. Now the change in the enthalpy formation. For example, so 1 mole of substance gives the delta H formation value. For water in liquid state it gives minus 242 and hydrochloric acid minus 92.4, then hydrobromic acid minus 36.4, then ammonia minus 46.1, then carbon dioxide minus 393.5, then methane minus 74.85, then ethane minus 84.6, next benzene plus 49.6, then acetylene plus 222.33, then methanol minus 239.2. These are the standard value heat of formation. Thank you.